Last section of chapter 4 is all about trees and counting techniques. So we're going to talk about different ways to show visually ways to count and then different techniques to count. I don't know why this guy is open, so there we go. Okay, so basically we already know the probability is the number of favorable outcomes to the total number in the sample space. Different ways that you can actually count this, though, besides the ways that we have before, are tree diagrams, multiplication rules, and then permutations and combinations. So a tree diagram simply displays outcomes of an experiment consisting of sequential activities, so it's just a matter of going in order and following the yellow brick road. The total number of branches equals the total number of outcomes. By the branches we mean the ends, so this one would have 4 possibilities, different ways like that. Each unique outcome is represented by going from the start to the finish. So if you start, you might be able, if you're going to flip a coin 2 times, this is the tree diagram, you might flip a head and then a head or tail, tail or head, tail, tail. So you have 4 options, different ways to go about doing that. Tree diagrams with probability, this is where they kind of make the most sense. So obtain probability of events. We can multiply probabilities as we go through different situations. So the urn example is the easiest way to talk about this. So if you have 5 marbles or something in an urn, there are 3 that are red, 2 that are blue, and we're going to select one, note the color, and then without replacing it, grab another one. So if we make a tree diagram, you might be able to get a red one or a blue one. And then given that you maybe get a red one, you could get a red one again, or else a blue one. So that's the idea. So if you have 3 out of 5 chance to get a red, if you already take one out, you have a 2 out of 4 chance to get a red and a 2 out of 4 chance to get a blue once that happens. Whereas if you get a blue one the first time, then the probability of getting red is 3 out of 4 compared to 1 out of 4 for blue. And this is taken right out of page 198 if you want to take a look at that. So like I said, there's 4 possible outcomes. What is the actual probability? Now this is your conditional probabilities, no different than we had last section. If I want to get a red and a red, I got to follow the yellow brick road. I'm going to go red and then red again. So what's my probability of the first? 3/5. What's the probability of the second? Well, that was strictly hinging upon getting the red the first time. I have a 1 out of 4 chance. So, or 2 out of 4 chance, excuse me. So 3/5 times 2/4. Then you multiply those together, solve or simplify down, and you get a 30% chance of getting 2 reds back to back out of that problem. Now another way to kind of talk about this, finding the number of paths without actually doing the tree diagram, it's simply just multiplying out options. That's all it is, multiplication rule. So if you're going to roll 2 dice, how many options do you have? Well, you have 6 options on the first dice times 6 on the second dice, so you have 36 total options. This is just the mathematical reasoning, N and F and E, and this is more or less a difficult way of basically saying multiply the possible outcomes together to get the possibilities of 2 events. So this extends to 3, 4, 5 different events. So the easiest example is, how many different outfits could you have? Now if you want to throw fashion out the window or matching and stuff like that, if you had 5 shirts, 3 pairs of pants, and 2 sweaters, how many different outfits could you have? You simply just multiply them together. 5 times 3 times 2. 5 times 3 is 15 times 2. There are 30 outfits that you could make. That's the idea of the multiplication rule. You just multiply together all the possibilities. More specific examples where it's a little bit tricky, you got to think about them, would be the area code example. Until a couple years ago, a 3-digit area code basically worked this way. The first could be any digit 2 through 9. And then the second digit had to be a 0 or a 1. And then the last digit could be anything. So how many different area codes are possible? Well, how many options do you have? 2 through 9. Basically, you can't have a 0 or a 1. So that means we had 8 options there. Times 2 options times, well, any digit would mean 0 through 9, so 10 of them. So how many different area codes could you have? 8 times 2 times 10. You multiply them together. Ordered arrangements. Now it's a little bit different if they're ordered. How many different ways could 4 items be arranged from first to last? Well, this is a little bit different. How many options do you have to be arranged first? 4. How many for the second spot once one's already taken? 3. And so on down the line, and you end up going 3 times 2 times 1 all the way down, and when you multiply them together you get 24. And And this leads you into factorial. What is factorial notation? This is read as n factorial. It's applied when n's a whole number, and whatever number you start with, you multiply all the way back down to 1. So n factorial would be n. This is the mathematical version, n minus 1, n minus 2, all the way down to 1. Just note that with factorial, 1 factorial and 0 factorial are both indeed 1. So just make sure you remember that. Now calculating it, it's really easy. It's not difficult. So all I really want to do is 4 times, this is 4 times 3 times 2 times 1. I've already done that, is 24. Now this gets time consuming, so I don't really want to do it all, but I show you here on the right how to get it on a calculator. If you type in the number 10 and then go to math, arrow over to the PRB tab, and then option 4 is factorial, and you can push the enter, you should get your 10 factorial number to show up. And that's how it works. So you can go ahead and practice with 6 factorial and 15 factorial on your calculator. It's just a matter of making sure you know how to do that. Why is this important? Because permutations and combinations use factorials, and that's the way it works. What are permutations? You probably heard this word before. It's an arrangement that order does matter. Nothing repeats, nothing's the same. So that's what's important about permutations. The number of ways to arrange in order. Here is your formula for permutations. You have n factorial over n minus r factorial. Note that this is the top formula on the right column of your formula sheet. So that is there for you. Another notation would be n permute r. I've also seen it as nr written that way. So anyway, it means all the same thing. So what does this consist of? Permutations means, here's a quick example. How many permutations of the letters A, B, and C are possible? How many different ways can you order A, B, and C without repeating? There are 6 ways. ABC, ACB, and so on down the line. You can read them. None of those repeat. None of them are the same. Okay? How many different 2-letter permutations of A, B, and C are possible? So it's no different, but we only want 2 letters instead of using all of them. So you go A, B, A, C, A, D, and so on down the line. I believe that there are 12 of them. Now how does this work in a quick shot? With permutations, here's what I like to do. 6 permutations, and if you're taking all of, with 3 letters and you're taking all of them, I'm looking for 3 letters. How many options for the first? 3. How many options for the second? 2. How many options for the last one? There are 6 ways. Whereas here, there are 2 letters, so I have 2 options. How many options for the first letter? There's A, B, C, or D. 4. How many options for the second letter? 3. Multiply them together, you get your 12. That's a quick way to do permutations if you know that they're going in order. Just figure out how many you're looking for. Okay? So I'm just showing you here using the formula on your page. 7 permute 3. And I end up getting 210. Okay? 6 permute 2. You could use the formula and go 6 factorial over 6 minus 2 factorial, which is 6 factorial over 4 factorial. And if you really want to write it all out, 6 times 5 times 4 times 3 times 2 times 1, which is 4 factorial. They cross out. Notice what's left. Your 6 times 5. That goes back to my previous page where I talk about I have 6 options. I'm taking 2 of them. How many options for the first one? 6. If I have that one, then it's 5. That's where that's coming from, and that's why this is 30. If I have 15 things and I'm taking 2 of them, and order does matter, then I could use the formula if you want. I could do the factorial thing if I want, or since I know I'm only taking 2, how many options for the first 15 times 14, and that would end up giving you 210. So that's kind of a neat little trick for permutations if you would like to do that. It's an application of this. Teachers chose 8 possible questions for an upcoming quiz. And how many different ways can 5 of these questions be chosen and arranged in order from 1 to 5? So order does matter with the order that he's putting them in on this quiz. So what happens is you have 8 questions. Okay? You're choosing 5 of them. So basically if you have 5 blanks, you have 8 options for the first problem. then 7, then 6, then 5, then 4. And if you multiply them all out, you get 6,720 different options for a quiz if I had 8 questions. It's kind of neat. Alright? The other thing we're going to talk about is combinations. Now, with permutations, order did matter. With combinations, they don't matter. And this is where it gets a little bit fun. So it doesn't matter the particular order. So list all combinations of the letters A, B, C, and D. So if you have A, B, and C, alright, A, C, B is the same thing because it's the same 3 letters. You can't use that. So that's the idea. You can't overlap or use things when it doesn't matter what order they come in. So really in this problem there's only 4 possibilities, okay? So let's kind of talk about this. Here's the formula. This is also on the top right corner of your formula sheet. And then here's some more notations. Just know that they can be seen that way. There isn't not one particular way that I'll show it. It doesn't really matter. Okay. So how the formula works: n is the first one, r is 3, so 9 factorial, and then your r factorial is 3, and then your n minus r would end up being 6, and you can just mathematically do it, and you end up getting 84. With combination, once again, with combination, there's no real short, quick way either. You kind of need to do the whole works. You can also do these on your calculator. I forgot to mention that. If you want to do 7, choose 3. This is how we say it. Type in the number 7 in your display. Then you need to go to Math. And then you need to go to your probability tab again, and then it's going to be, you have to find the option. I think it's option 3, perhaps maybe 4. Don't quote me on that. And you just get, and you'll end up getting this C in there, and then you type in 3 after it. And once you do that, you push enter, and you'll get the number 35 to show up. And then 15, choose 2 would be 105. So you can do that via your calculator with the Math probability tab, or you can use your formulas that are on your page and just use the factorial key. So either way works. Here's an application. So a teacher has chosen 8 possible questions for an upcoming quiz. Again, how many different ways can 5 of the questions be chosen if order doesn't matter? What if I don't care about the order? What if I just want to pick 5 numbers? Yeah, that's a little bit different. You're going to have a lot less options when order does not matter. Because you do a factorial, and then you got to divide out all the possible repeats. So then you end up only getting 56 possible options compared to the obnoxious amount before. So that is it. Here's going to be our last assignment for this chapter. We're going to do 1 through 11 odd and 13 through 30 all. Hope you all have a great day.